All right, so in this video, we're going to work through this practice test for TEKS 3A, 3B, 3C, and 3D. We'll start with number 1. This question is similar to question 1 from the 2019 test. What is the slope of the graph of y equals 15x minus 22? Well, the equation that we're given is y equals 15x minus 22. This equation is in the form of the slope-intercept form equation, which is y equals mx plus b. And the m stands for the slope. So the position of the m indicates that 15 is the slope of the line. So I would choose, in this case, option C, 15, because the slope is 15. On to number 2. Similar to question 51 from the 2018 test. Here we're given a pair of points, 6, negative 15 and negative 4, 19, and we're asked to compute the slope of the line. Okay, so there are multiple ways to go about this. I'll show both methods in this video. The first would be to just compute the slope using the slope formula. So there is this formula that says that the slope of a line, which we call m, is equal to y2 minus y1. In other words, the difference in the y coordinate over x2 minus x1, or the difference in the x coordinates. In other words, the change in y over the change in x. So the next step would be to label our coordinates, x1, y1, x2, y2, and then just sort of plug them into this formula. Let me switch the color up a little bit here. So I'd say equals 19 minus negative 15. You're going to end up with double negative there. Be careful. And then x2 is negative 4 minus x1, which is 6. So there's a lot of weird placements here of the minus and negative signs. You got to be real careful that you don't mix them up. So this double negative becomes a positive, and we end up with 19 plus 15. If we don't know what that is, just let the calculator help us here. 19 plus 15. Okay, that's 34. Over, and then negative 4 minus 6. Once again, if you're not sure, just go in here, make sure to press the negative symbol. Okay, negative 4 minus 6 gives us negative 10. Okay, so this is negative 10. Well, now all that's left for us to do is to reduce this fraction down. If you have no idea what to do, just take 34 and divide by negative 10. Okay, now, you know, if that's how the answer is presented, you're good to go. But if you need to, you can hit alpha y equals, enter, and actually put this in as a fraction, and the fraction will be reduced for you down to negative 17 over 5. So what I would say is the answer is either negative 3.4 or negative 17 over 5. So we'd say it's either negative 3.4 or negative 17 over 5. It all depends on what your answer choices are. Well, going through and looking for either of these, I find negative 3.4 is one of my answer choices. So that's the correct answer for number 2. Now, I said there were 2 ways to do this. The second way might be preferable for some people who are less comfortable with the symbolic math. And I'll just kind of push this off to the side here and show you what I mean. We're going to create 2 columns. We're going to call one of them L1 and the other one L2. The L1 column will be for our X values. The L2 column will be for our Y values. This is going to go in the calculator here. So our X values here are 6 and -4. Our Y values that correspond to those X values are -15 and 19. Now, the order doesn't matter as long as you're consistent about matching your X and Y values. So now this becomes the table that you put into stat edit. The process is stat edit. Okay, type the information in and then hit stat calc 4, and then you hit enter 5 times. It's going to give you the answer in the form y equals ax plus b, where a is the slope. Okay, so let's go see what that looks like. We hit stat, it's this button right here, and then just hit enter and type in your table. 6, enter, -4, enter. Then in the L2 column, -15 and 19. Okay, so our table looks exactly like what we drew. We just hit stat calc 4, enter, 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 enter. And that gives us the equation of the line. The only thing I'm interested in is the slope, which is -3.4. Once again, we got -3.4. So it's really important that you're comfortable with either method, but the one that most students find the easiest is just plugging it into the calculator. Okay, moving on to number 3. We're looking at a question that's similar to number 16 from the 2017 test. What is the slope of the line represented by 6x minus 18y equals 54? Okay, once again, we're asked for the slope, and then we're given an equation in standard form. Now, what do I mean by standard form? I mean an equation that takes the form ax plus by equals c. And if you kind of parse this out, okay, we can figure out that A, B, and C are just given to us. A is 6, it's the number in front of the x. B is actually -18 because it captures the sign, okay? So we say B is -18, and C is 54. Now there's tricks, okay, with standard form. One of the tricks is that you can find the slope of standard form equations by simply doing -a over b. Okay, so if a is 6, then it's like therefore, right? -6 over b, which is -18. Well, now we've got -6 over -18. We can divide a 3 out of both 6 and 18, and that gives us 2 over 9. And you can, right. What I mean to say is we can divide a 6 out of both the 6 and the 18, which gives us, and we're actually going to pull a -6 out. So I've kind of lost my track there. So -6 divided by -6 equals 1. -18 divided by -6 equals +3. So your reduced fraction is 1/3. I lost track of what I was doing there. You know, if you don't know how to reduce a fraction, your calculator here would be your friend. Just go ahead and alpha y equals enter. Plug this fraction in as -6 over -18. Okay. We're going to reduce that fraction by just hitting enter. It tells us it's 1/3. Okay. So looking at our answer choices here, I see that I've got 1/3 here for answer choice D. Now, answer choices might be different in your document, but it's 1/3. Sorry for the mistake. It happens. Give me just a second. Okay, so now we're on to number 4. Similar to 2019.5.3BR, what it means is the fifth question from the 2019 test. This is TEKS 3BR. And this TEK, they like to use the term rate of change instead of slope, but it's basically the same thing as long as it's a linear relationship, which it is. The table shows the linear relationship between the height in feet of Christmas trees on a tree farm, Y, and the number of years since they were planted, X. What is the rate of change, okay, this is important, of the average height in feet of the trees on the farm with respect to the number of years since the trees were planted? What it's saying is, what is the change in the Y value with respect to the change in the X value? In other words, AKA, what is the slope of this line? Okay. So if you wanted to compute it by hand and you know that it is a linear relationship, you only need to compute the change in Y and X between these two numbers. Now, if the STAR test tells you that it's a linear relationship, you can trust it. Okay, where normally you'd have to check all these. You only need to check this. So 1 to 5, that's plus 4. 1 plus 4 is 5. And then from 1 to 4, that's plus 3. Okay, so remember, in this version, we're looking at slope or rate of change, constant rate of change, as the change in Y. That triangle means delta Y, which means change in Y over change in X. Well, okay, my two changes are, the change in Y is 4 over 3. Okay, so what this means is, if we kind of bring the English language back into it, it grows 4 feet, or 4 inches rather, every 3 years. Okay, so the change in Y is 4 inches, the change in X is 3 years. So 4 inches every 3 years is option I. Okay. All right. So, I'm kind of live editing this document as I do it. And I think if I'm going to make this change be inches, then I should probably make this height in inches. But then that doesn't make any sense. So either I have to make this inches or I have to make this feet. And these would all have to be feet. Yeah. Makes more sense that way, doesn't it? So that's what we'll do. We'll make sure we change number 4 to reflect that the change is feet every year. Okay. Like that. Okay. Moving on to number 5. The graph shows the linear relationship between the maximum area in square feet Y that can be painted and the number of gallons used X. Which of these best represents the rate of change of the maximum area painted with respect to the number of gallons used? This looks like 21 from the 2018 test. Okay, so basically we're trying to compute the slope. Your rate of change here is the direct indicator of that. Now, the temptation here would be to say it's 400, okay? Because it looks like in the background you can find a lattice point and say, okay, go up 4 over, well, be careful here because you'd really be going over a half. That doesn't work. So what you need to think is, okay, go up 800 over 1. That makes more sense. So it's plus 800. That's the rise. And the run here is 1. So I would think the answer is 800 square feet per gallon. And that's kind of the whole thought process there. Moving on. Number 6, the function y equals 4.25 plus 1.2, open parentheses, 2x minus 3 can be used to determine the cost in dollars for a train ride for X miles. What is the rate of change in the cost of the dollars? Okay, now be careful here, because the problem that this problem is kind of the child of did not have a number next to the X inside the parentheses. You have to be careful here. What you must do is multiply 1.2 times 2 before you find the correct rate of change. So let's see, 1.2 times 2. Well, 2 times 2 is 4. 1 times 2 is 2. Bring over this dot. If you didn't know that, you could just do it in the calculator. It's $2.4 or $2.40 per mile. And that would correspond to letter choice H. Moving on. Number 7, which of the following graphs best represents negative 7y equals negative 5x plus 42? Well, there's actually a couple of novel ways to go about the answer here, but what most students seem to find easiest to do is to simply divide each term by the coefficient in front of the y variable to get y by itself. They just divide everything by negative 7. Okay, we'll just kind of move our work over here. Okay, so these cancel and y is now by itself. And then negative 5x over negative 7 is just 5 over 7. The negative over negative cancels out. I got 5/7 x. 42 divided by negative 7 is minus 6. All of that could have been done in the calculator. You could have computed each of those. If you know your tables, though, 42 divided by negative 7 is negative 6, just pops into your head. It's easy. So I'm looking for an equation that has a slope of 5/7 and a y-intercept that is at negative 6. So one thing I want to keep in mind is when you have your equation in the form y equals mx plus b, like we do here, then you know that this is the y-intercept, negative 6, and this is the slope. Okay, so one thing to notice about the slope is that it is positive. That means that, just very roughly speaking, we're going to have a line that has a positive slope that crosses the y-axis at negative 6. That's going to help me eliminate, that little picture right there is going to help me eliminate a lot of my incorrect answer choices. For example, it can't be A, C, or B because they're all downward sloping. So right away, I'm going to zoom in here and make sure that this makes sense. Yes, it's crossing the y-axis at negative 6, but is it slope up 5 over 7? Well, we'll see, right? This is at negative 6. It's really hard to tell. But if I went up 5, it'd be like right there, and then over 7 would put me right there. So this is up. Oh, I don't even want to try it. 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6, 7. Okay, worked out good. So up 5 over 7 to the right. It's correct. The answer is D. So I would answer that question anyway. I just can't help myself. There's one other little trick here that one student thought of that I thought was very good. It's kind of how my brain thinks as well. He said, okay, I got negative 7y. This was the original. Equals negative 5x plus 42. And he said, we're only one step away from making this a standard form equation. Just move the 5x to the other side by adding 5x to both sides. And then you would have a standard form equation that looked like this: 5x minus 7y equals 42. And then he uses the tricks. So the tricks for standard form is that if you know what A, B, and C are, we know A is 5, B is -7, and C is 42, then you can tell a lot about this. For example, you know that the X-intercept is at C over A, which would be 42 over negative, or 42 over 5, whatever that is. You know that the Y-intercept is at C over B, which is 42 over -7. We already determined that that's -6. And we know that the slope is -A over B, which is -5 over -7, which we already determined was 5 over 7. So let's see. 5 goes into 42 8 times 8 and 2/5. What is that? 8.4. And then 42 divided by -7 is -6. And then this is 5 over 7. So let's make sure that this actually looks like it crosses at 8.4. If you look in real close here, it does kind of go beyond 8. Looks like it would cross past 8. So another way of kind of getting the answer using the standard form tricks. That's really cool. I like that. Moving on, number 8. The graph of linear function q passes through the point 6, 1 and has a slope of 1/2. What is the 0 of q? The most important word in this whole question is 0. Pardon me. 0 means the x-intercept. Okay, where does it cross the x-axis? That's the question. Well, how would you figure it out? Well, there's two ways, and I'll show both. But the way that most students like is they like to plot this point. See, because we're given a point here, and we're given a slope. So what most students like to do is they instantly look at the picture and say, all right, 6, 1 is located right here. Okay, so these y-axis figures are denoted in 2s. So we have to think halfway between would be 1 right there. So there, and now I would go up 1 over 2. So the way that they conceive of the slope is they say, okay, this time I'm going to think of slope as rise over run. So I'm going to rise 1 and run 2. Going back here, you can say, all right, we're going to go up 1 over 1, 2. 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 So you could go backwards as well, right? So you could go down 1 over 1, 2, and now you're here. So these are the points that would form the line. And if you had a ruler, you could make sure that they all fell on that same line, which they would. A little bit of error into my drawing there. Basically, this is what the line would look like. And you can plainly see that it's crossing at 4. So we say 4 is the 0. Okay. Bingo. Now, the more technical way, since that is kind of a painstaking process that requires a lot of focus on writing stuff down on a graph and drawing things, more visual, the correct way to do this algebraically is to use the point slope form of a line. Okay. Now that point slope form is y minus y1 equals m, open parentheses, x minus x1, close parentheses. Now it turns out we're actually given the point, and we have x1 and y1, and we're given the slope, so we're given m. We just have to plug these numbers in. So I've got y minus y1, which is 1, equals m, which is 1/2, open parentheses, x minus x1, which is 6. If I keep working this out, I have y minus 1 equals 1/2 x. And then 1/2, it's basically 1 times negative 6 over 2 is what's going on here. When you distribute that fraction 1/2 over to negative 6, and so we have y minus 1 equals 1/2 x. And then 1 times negative 6 over 2. 1 times negative 6, negative 6. Negative 6 divided by 2 is negative 3. Final step, add 1 to both sides. And we have y equals 1/2 x. Negative 3 plus 1 is negative 2. And to find the x-intercept, we can see that this is the y-intercept is negative 2. But to find the x-intercept, we need to cancel out the y there and put a 0, because we want to know what is x when y is 0. Well, okay, that's how you do it. Say, well, 0 now equals 1/2 x minus 2. Add 2 to both sides. And we have 2 equals 1/2 x. Well, you just multiply by the reciprocal, which is 2 over 1. And that cancels out everything here. You're left with x by itself on the right equals 2 times 2, which is 4. And that's another way to arrive at x equals 4. Either way, you're going to get the same answer. Just one of them involves a lot more math. Okay, the graph of linear function m passes through the points 4, 0 and 1, negative 18. Which statement must be true? Okay. Well, if you're going to draw this, you're given a blank picture here. The first thing you probably want to do is actually plot these points. Whenever I see points, I just automatically want to say x1, y1, x2, y2. But I'll go ahead and plot them. 4, 0 is right here. And then 1, negative 18 is right here. If I fit a line to these 2 points, I can get a picture of what this graph looks like. Kind of. That'll work. Love it. Okay, so it appears to have a y-intercept of negative 24, an x-intercept of 4, and what's the slope? Let's see. I'll start here and go up. See, it's going up 2, 4, 6 over 1. So looks like it's got a slope of 2, 4, 6 over 1. So it looks like the slope is 6. It looks like the x-intercept is 4, 0, and it looks like the y-intercept is negative 24, which would be 0, negative 24, depending on what they want. So let's see if any of those. It says the 0 of m is 4. Well, okay, bingo. I already found something that's true. The x-intercept is 0, 4. Well, no, it's 4, 0. Thank you very much. It's wrong. The slope of m is negative 6. Well, we found that the slope was 6, and either way, this is a positive left to right. It's going up, so it's positive slope, so it can't be a negative slope. The y-intercept of m is 24. Well, we found the y-intercept to be negative 24. Thank you very much. So this is incorrect. The only correct answer is A. This 0 of m is 4. I could show an algebraic solution to this, but it's unnecessary. One of the things I worry about is questions like this. I'm concerned that a computer-based test is going to prevent students from directly editing the blank graph that they're provided, and I'm not sure they have to recreate it on a piece of paper or something. So maybe I should show what you would do if you had to. Just before we lose the momentum here, we could create an L1x and L2y table here and say, okay, my L1 values are 4 and 1, and my L2 values are 0 and negative 18. Let's go into our calculator. hit stat edit and go clear these tables here. And we'll put our values in. 4 and 1. 4, enter, 1, enter. And then go over and do 0 and negative 18. So 0, enter, negative 18, enter. Okay, stat calc 4, enter, enter, enter. Stat calc linreg ax plus b, 4, enter, 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 enter. So y equals ax plus b, y equals 6x minus 24. So my equation is y equals 6x minus 24. I can stick that into y equals and get all my information. So 6x minus 24. If I then look at second graph, I can find that the y-intercept, where x is 0, y is negative 24, and I can find the x-intercept is when x is 4, y is 0. So there's my two pieces of information. And that's how I would do it. You know, if I wasn't able to actually directly draw on a piece of paper and I wasn't provided some digital tool to make these lines, I would definitely use the L1 and L2 stat edit stat calc method. Moving on. The water level of the Trinity River was measured each day during a 2-week period. The graph models the linear relationship between the water level of the river in feet and the number of days the water level was measured. Which statement best describes the y-intercept of the graph? Let's zoom in on that. And that y-intercept is 18. Well, so this is the like the height, okay? And this axis down here is time. So the height of the river starts at 18 and then it goes up to whatever this value is. Okay, so let's see. And we're asked to describe what this y-intercept means. Okay, so the water level increases at a rate of 0.75 feet per day. That has nothing to do with the y-intercept. The water level was measured for 14 days. Nothing about the y-intercept. The initial water level was 18 feet. Okay, so one easy way to get this is just see, well, that's the only one that has an 18 in it. And also, that's what the initial water level is. It's the y-intercept of the graph. We don't care about the maximum level. Moving on. A paper airplane was thrown from the top of a football stadium. The height of the paper airplane above the ground can be found using the function y equals a negative 0.8x plus 16, where x is the time in seconds the airplane has been in the air. Question: how many seconds did it take the airplane to reach the ground? Translation: what is the x-intercept? And the reason I know that is because this is height and this is time. So it says here that the person throwing the paper airplane, or the height of the paper airplane here, is at 16. Okay, that's where it starts, and then it falls down. Okay, it flies through the air and falls down over some number of seconds. So we just want to find out where it hits the ground. Okay, so we know it starts at 16, and we want to know, how long does it take before it is 0 inches or 0 feet above the ground? Well, here's my recommendation. Take this equation, y equals negative 0.8x plus 16, and graph it in Desmos, okay? Because Desmos is going to be available to you, and this is the easiest way to get this answer. So let me pull up a browser here. Running Desmos. And the equation is negative 0.8x plus 16. So y equals, I'm working over here, y equals negative 0.8x plus 16. Okay. All right, here we go. And so there we see that it starts at 16, and after 20 seconds, it hits the ground. And that's really easy. I like that a lot better. I know that it's 20 seconds. That was that simple. If you didn't have access to Desmos, you could use your calculator and just go in here and plug it into y equals. That would be negative 0.8x plus 16. Okay, and then you would hit second graph. And you'd want to go find where y was 0. There. See? When x is 20, y is 0. So that's how I know that that's the correct answer on the TI calculator. Okay, moving on. Which line appears to have an x-intercept of 12 and a y-intercept of 8? An x-intercept of 12, okay, important information. It's where it hits the x-axis, of negative 12, rather, and a y-intercept of positive 8. So it hits the y-axis at 8, the x-axis at negative 12. Well, this first line hits the y-axis at 8, which is good, and the x-axis at positive 12, which is bad. So that F's not F. G. Okay, here it hits the y-axis at negative 12, which is bad, and the x-axis at positive 8, which is bad. So this is not G. Looking at H, it hits the x-axis at negative 8, which is bad, and the y-axis at negative 12, which is bad. Okay, so it's not H. Hopefully it's I. It hits the x-axis at negative 12. That's good. And then it hits the y-axis at positive 8. That's great. So the answer is I. And I think that what I'm going to do is halt the test right there, because that is all that we learned. And I'll hold off on that 3D stuff for later, because I don't want to go further in this test. I think this is a good test. What is this, 12 problems? And how long did it take to record it? Okay, this took 37 minutes. That's perfect. So if I give this tomorrow, this is plenty of time to do this. Okay, so basically my edit here, I'll pull the 3D out, and the only other thing I need to do is I need to fix number 4, okay? Any other things I need to fix? No. I'll just have to reprint this. It'll be a shorter test, but a good test. I think that's a good test of whether you understand TEKS 3A, 3B, and 3C. All righty. Thanks so much for watching. Hope this was helpful.